All right, so we basically covered all the power analysis equations, and we talked about apparent power, real power, the power triangle, reactive power, and now we're going to look at three-phase systems. So what in the world is a three-phase system? We're going to get into that, but first we need to do a little bit of a review on phasors so that this will make sense. And so previously, I think in Module 1, we showed that we can represent a number in the complex plane, right? We can represent it by its real part and its imaginary part, and we can write that out as a rectangular form for this particular point in the complex plane, which would be, in this case, I could call it z is going to be equal to 6 plus j4, and that would be the rectangular representation of z. I can also represent z as a phasor, right, which has a magnitude here, some magnitude, which I could write as 7.2, which is basically 6 squared plus 4 squared, take the square root. And we can also characterize it by the angle that it makes with the positive x-axis. So in this case, it would be, I just chose some value 33. Well, I didn't choose this value arbitrarily, it's geometric. But I can represent this value z in two different ways, right? I can represent it as in rectangular by the x and y coordinates, or the real and imaginary coordinates of the point that the arrow points to, or I can represent it by the actual characteristics of the vector, which are how long is that vector and what angle does it make with the positive real axis, okay? And so we talked about, I drew this dotted line here, and I talked about what would happen if we swept this vector around in a circle, right? If I swept it around in a circle, this is not a great circle, and I were to take, snapshots of where is my vector at different points in time, or not even at different points in time, but rather at different angles. And if I were to keep track of that y value, right, it starts at, at 0 degrees, the y value is 0, right here. And then I sweep it a little bit, and it goes up a little bit, and I sweep it a little bit more, and it goes up a little bit more until it reaches some maximum value at an angle of 90 degrees, right? So at 90 degrees, this thing reaches a maximum. And then on the downfall to 180 degrees, it comes right back down. And so at 180 degrees, it hits 0. And then it starts sweeping into the negative y values. So it starts coming down here, and it hits a negative maximum at 270 degrees, which is right here. And then it completes a full cycle. I kind of cut off my circle here, but you get the gist of what I'm doing. Comes back up, and at 360 degrees, the whole cycle repeats. And that is what a sine wave is, right? We talked about that being what a sine wave was when we take that that phasor and we sweep it around in a circle. I don't know what I lost there. Oh. We sweep it around in a circle, and we plot the y value as we vary the angle. That is what a sine wave is. If we plot the x value, we get a cosine wave, right? If we plot the x value, we get a cosine wave, which looks like this. Okay. And so this is important for three-phase circuits, because what we're basically going to have, and I'll show it in the next slide, but we're basically going to have three different phasors. Let me actually draw these axes in gray so that we can look at our phasors here. We're going to have three different phasors. We're going to have one here. One here. Then we're going to have another one that's right about here. That's going to be at 120 degrees counterclockwise. And then another one that's at minus 120 degrees. Okay, and these three phasors are going to all rotate at the same time, at the same rate. And so each one of them is going to generate a different signal, right? One of them is going to generate a signal that starts at 0 right at the beginning and, creates this sine wave. The next one is not going to hit 0 until 120 degrees. So it might be like right there. And then the third one is not going to hit 0 until 240 degrees, which is right here. And so this is what we get for a three-phase system. We have these three different phases that are creating three different sine waves, and that is how real power is generated and distributed, okay? I just wanted to show the phasor representation of what that looks like as these phasors sweep around in a circle, right? So this is the figure that is given in the textbook, and we'll talk about it more in the next video, but that's kind of what I sketched right here. Is I've got three different phasors that are, you know, at a starting value, they're out of phase from each other by 120 degrees. This one is 120 degrees behind this one, which is 120 degrees behind that one, and so on. But if we rotate all of them, right, we just end up with three phase shifted sine waves that are all 120 degrees out of phase from each other, right? Their peaks are always 120 degrees out of phase. Their zeros are always 120 degrees out of phase, and so on. And so this is what we do in three-phase power. I'm going to get to a slide where I talk about why we do that. It's still probably entirely unclear what I'm even talking about, but just so you know from a phasor perspective what's happening, just think of it as three phasors. Like we were talking previously about how a sinusoidal source can be thought of as just a vector sweeping in a circle. Well, a three-phase source is basically just three different sources that are all 120 degrees out of phase. So that one's going to be angle 0. This one would be angle 120. This one would be angle minus 120. And we're going to power what's called a three-phase load. And so this is just an intro. I just wanted to take this time to review the phasors and kind of introduce the concepts. Don't panic if this seems like chaos, because it does get a little bit overwhelming pretty fast. But I just want to make the phasor review clear to show that if I had three, phasors sweeping in a circle like this, it would just generate three different sine waves that are all 120 degrees phase shifted from one another, right? The same way that the signal was generated here that I drew, these three sine waves would be represented just like this if we were to look at them versus omega t in this case. We're plotting this as, I guess I did it in terms of degrees here, but you could plot it in terms of angle too. Okay, so I'm going to go ahead and end this video. Just wanted to do a brief phasor review. In the next video, I'm going to start introducing the three-phase generator and talking about three-phase supplies, and then I'll kind of do another video right after that on why we want to do three-phase power. Why is power transmitted in this way? What are the benefits? What are the drawbacks? Etc. Okay, so I'm going to go ahead and end this video here.